Okay, this is the problem that we started in class. We didn't finish it, but I think we went over it kind of fast, so I thought it would be good to go over it again. So this is from 2014 from the exam, question number 3. And this is all about the second fundamental theorem of calculus. So the first question is to find g of 3. So if we want g of 3, that means wherever there's an x, we're going to put a 3. Okay, and then you need to recognize that this notation means the area under the curve from -3 to +3. So that would be -3 to +3. So we're talking about this little triangle over here, and then this big triangle over here. So the area of the big triangle is just going to be 1/2 base times height, and the base is this piece right here. So that's 1, 2, 3, 4, 5. And then the height is going to be this, which is 4. Okay, so half of 20 is going to be 10, and that means that this big triangle up here is equal to 10. Okay, then we need the area of the little triangle, so that's going to be 1/2 the base, which just goes from here to here, so it's just 1 times the height, which is 2, and that will give us 1. But you need to recognize that this is below the axes, so that means it's a -1. So we had 10 and -1, and that will give us 9. And that was worth 1 point on the AP test. Okay, now we're up to part B, and this is kind of a long one, so I'm going to have to write and erase and write and erase, so sorry about that. Okay, so the question is asking, when is G increasing? Forget about the concave down for now. So we should know that if G is increasing, then G prime is greater than 0. Okay, hopefully everyone knows that. And Jennifer, I didn't forget you about that chart. Okay, so we need to know when is G prime greater than 0. So what is G prime? So we know G of x, so G prime of x would just be taking the derivative of the right side. And now you can see that this is the second fundamental theorem of calculus. And you're just going to take this x and you're going to put in here. So therefore we can say that G prime of x is just equal to f of x. Okay, let's get this out of here. Okay, so since G prime is equal to f of x, I can say when is f of x greater than 0. Okay, so let's look at our picture here. So this is the function of f, and when is it greater than 0? This entire piece is greater than 0. Okay, so f of x is greater than 0 from -5 until it gets to 2. Okay, so we just completed that first part. Now let's go to the next part. Okay, when is G concave down? Okay, so G is concave down when G double prime is less than 0. Okay, so what is G double prime? Well, we already found that G prime is equal to f of x. So we're just going to take another derivative. And we know that G prime is equal to f prime. So when is f prime less than 0? Okay, so this is the graph of f. And when is f prime less than 0? Okay, so f prime is less than 0 when f is decreasing. And this is the graph of f, so when is it decreasing? From here to here, and from here to here. So it's decreasing from -5 to -3, and then it's decreasing from 0 until it gets to 4. Okay, so the question is asking, when is it doing both these things, both increasing and concave down? Just get another color. Okay, so you're going to look on the different intervals and see what numbers are included. So -5 is included in both. -4 is included in both. Negative 3 is included in both. Negative 2 is not included in both because you can see here it stops at negative 3. So from negative 5 to negative 3. Negative 1 is not included. 0 is included. 1 is included. 2 is included. But 3 is not included because this is stopping here at 2. So it's from negative 5 to negative 3, and then from 0 to 2, and of course you could write it like this. If you prefer. And you got 1 point for the actual answer, and then it was 1 point for all your work before, writing things like g is increasing, g prime is greater than 0, that means f of x is greater than 0, etc. Okay, so that was the answer for part B. Okay, now we're up to part C, and we're looking at this function, and we need to find h prime of 3, but before we can find h prime of 3, we're going to need to find h prime. So this is going to need a quotient rule. So it's going to be the bottom times the derivative of the top minus the top times the derivative, times the derivative of the bottom, all over the bottom squared. Okay, and now that we have the derivative, we can find h prime of 3, and that means wherever there's an x, we're going to put a 3. Okay, so we're going to have 5 times 3, which is 15, times g prime of 3, minus g of 3, times 5, all over 25 times 3 squared, which is 9. Okay, and now we just have to figure out what all these things are equal to. So we have 15 times g prime of 3. Okay, so what is g prime of 3? Okay, I'm going to do this in another color. So we already said that g prime is equal to f of x. So if I want g prime of 3, that means I want f of 3. So I'm going to look at my graph, and when f is 3, it's equal to negative 2. So we have 15 times negative 2. Just make some room here. Okay, minus g of 3. So g of 3 we did in part A over here. We found that that was equal to 9. So minus 9 times 5 all over 225. Okay, and 15 times negative 2 is negative 30. Negative 9 times 5 is negative 45. This gives us negative 75 over 225, and that could be reduced to a negative 1 over 3. So the point values were, if you found h prime of x, you got 2 points, and then to find the final answer, you got 1 point. Okay, and finally, this is part D. So it says to find the slope of p, so that means we need the derivative of p. So here's p right here. So the derivative of p, sorry, this is just not cooperating today, I don't know why. Okay, so the derivative of p would be f prime of x squared minus x times the derivative of the inside, which is 2x minus 1, so it's like a chain rule. And we need to find this derivative when x is negative 1. So that means wherever there's an x, we're putting a negative 1. So we get a negative 1 squared minus a negative 1. And then we get 2 times negative 1 is negative 2 minus 1. Okay, negative 1 squared is obviously just 1. Whoops, where's my f prime? Okay, hang on, let me just fix this up a little bit. Sorry. Okay, it's f prime of negative 1 squared minus a negative 1, okay, times 2 times negative 1, which is negative 2 minus 1. So we get f prime of 1 plus 1, which is 2, times negative 3. So we need f prime of 2. So here's 2. This is the graph of f, and we need the slope there. So hopefully you notice that this is a straight line, so the slope is the same everywhere on that line. And we are given 2 points. We have 0, 4. And then we have this, 4, 4. So y2 minus y1 over x2 minus x1. And we get negative 2. So f prime of 2 is negative 2 times negative 3. And we get 6 as the answer. And so the point value was, if you found f prime, you got 2 points for that. And then if we got the final answer, it was 1 point for that. And we're done. So this took me 11 minutes to do with all of this, talking and stuff. So definitely it can be done within 15 minutes.